Okay, all right. Study guides can be pretty tedious. You know, it's good to kind of spread them out. I'm kind of knocking this out all at once. So let's see. We're going to use a remainder theorem here and then the factor theorem here, okay? So state if a given binomial is a factor. That would require the factor theorem. And you'll notice that the answers are either yes or no, okay? Now, these should be part, as long as you know synthetic, I mean, notice how much synthetic division we're doing on this test. It's a lot. It's a very powerful algorithm here, okay? Now, here's the thing, though, that you got to remember. For the remainder theorem, you're not going to change the sign like you do when you're dividing by other binomials, okay? This is the number that goes into the window immediately, okay? So don't change that, all right? Just like this guy, okay? He's going to be a positive 6, okay? So just kind of keep that in mind. Now we got 3, 2, 1, 0. This guy's ready to go. Now, this theorem says that the remainder that you get at the end of the synthetic division is actually the same thing as plugging this guy into the function. Now, the idea here is that it is fast and efficient, okay? So I'm doing nothing but synthetic division. This is -2, and so the answer is -2. That's the remainder. So therefore, if I plug -6 into this for the n and just cranked it out on a calculator, it would be -2. Now notice that this is actually faster than plugging it into your calculator where you could possibly get a typo. Okay, same thing with this guy. 1, 3, 2, 1, 0. This guy's completely in order. There we go. All right, so drop the 1. All right, 1 and then 6, that goes to 0, 0, 4, and then 24. Okay, it looks like this guy's actually -1. Now, I don't see it, but I do see none of these, so I'm going to double check. 1, -6, 4, -25, 6 goes here, drop it, 6, add it, 0, 0, 4. Yeah, okay, so the answer there is none of these. Okay, keep going. Now we don't have a net, but we do have a 5. So we've got a 5. 4 is missing. So put a 0. -6 for the 3. 1 for the 2. 12 for the 1. And -8 for the end. Okay. So 1, -2, -2, +4, -2, 4, 5, 10, 2, -4. The answer is -12. All right, 6, imagine plugging that in. That would take forever. I think this is going to be a lot quicker. If I just did 1, -2, -19, -36. Like already, I probably would have typed in the wrong number into the calculator. Okay, so let's see what happens. Now you can make a mistake with this, obviously. And this is a 6th-degree polynomial, so this is quite the thing to do. 4, 24, that's 5, 30, -6, -36, -3, -18. Okay, that's +6, so that's 36. So that's going to be -6. The answer is -6. Okay. All right, so let's go ahead and just knock out the rest of these, since the remainder theorem is just, it's synthetic division. I mean, put that on your study guide. Remainder theorem is just synthetic division. Okay, factor theorem right here is just synthetic division. So don't think that you got to do anything special. But do notice, though, I do have a binomial, so I'm going to put the number that is 0, okay? So now we got 1 for the 5, -6, -2, 16, 11, and 4. They're all in order. Okay, now what I'm looking for is the factor theorem says if I end up with a 0 at the end of this, then yes, it is a factor. Okay, but I need a 0, like perfect 0 at the end. So 1, 2, -4, -8, -10, -20, -4, -8. Now that's 3 and 6. That's a 10. It is a no. Okay. All right, so put 2 here, and then a 1, a 5, negative 10, and negative 12. These guys are all in order. Cool. 1, 2, 7, 14. That's a positive 4. That's 8. That ain't 0, so that's a no. Okay? What are you going to do? They're both no's. So now we got 4, right? Positive 4. And then a 1, negative 9, 30, and a negative 40. So drop the 1, 4, negative 5, negative 20, negative 10, negative 40. Now let's just, oh, that's a positive 10. 40, that is a 0. So the answer here is a yes. Okay, so that was a remainder of 0. And then finally, 8 goes here. So we got a 4, negative 28, negative 32. Then a 0 for the, you notice that there's a x missing, x squared missing. Okay, and then a 2, and then negative 6. So if there's a positive 5, you have 1, 2, 3, 4, 5, 6 terms. Okay. All right, drop the 4, 32. That is going to be positive 4. That is 32. That goes to 0, 0, 0, 0, 2. And then that's going to be 16. That's going to be a positive 10. And that is a no. Okay, so just remember that it's a 0 that makes a yes. Any other number other than 0 is going to give you a no. All right, good luck.